but it's still the future, unfortunately. Okay.
Yeah, let's see.
What?
Hey. Okay. We seem to be live. So I will share my screen. Cool.
Okay, I'll look at your screen. Let's,
Yeah. Okay, let's start with a easier one, maybe. Yeah. Okay. So today we're gonna prove more things about lists. For the drop function and the take function, and there's even a min function in here, which is pretty annoying to work with, but we'll see what we can get done. And the take function. Yeah, where's the split? If we get lucky, we'll get to the split function. Oh, it's not a function. It's just dropping and taking. And yeah, maybe this will be our last time we do lists. So hopefully next time we'll do some meta programming, trying to combine all the theorems we've proved before into a tactic that can prove things about lists for us. So we don't have to do all this tedious work. But one more of these, because it's actually pretty fun. It's becoming pretty fun now that we've learned a lot of the tricks. So yeah, I think, yeah, and maybe, yeah, today we have Paul with us and Gregor. And Gregor is having some technical difficulties, but it might work out. It might work out.
Paul is having some brain issues.
Yes.
So
Yes. Yeah. Yeah. I'm not at my.
We'll see. Oh, is that on your screen or my screen? A new version of Go PLS. Okay.
Yeah.
No, that's yours.
Yeah, that's mine.
Try clicking on it.
They should just. Yeah, I should somehow turn that off. Okay, so I'm gonna hopefully this is an easy one. I don't know. We're just gonna check the length of a list. If we drop in characters from it, then that length should be the length of the list minus n, right? So nothing weird. So we drop the first.
It's got a minus.
Sorry?
But it has a minus in it.
Yes, it has a minus in it, which is actually.
It's also just a bit terrifying.
Yes, yes. We could start with this take that has no minus. Maybe that's the easiest one to start with as a warm-up.
Okay.
So this just says if we take the length of x's from the concatenation of x's and y's, then we just end up with x's. So that, yeah, let's rather start here. I want to revert y's. I don't know why. And then do induction on x's.
Revert y's.
Oh, y's, yes.
Yeah.
Oh, yeah. Oh, this is the syntax. Thank you, GitHub Copilot. Then there should be cons x
something. Yeah.
Induction hypothesis. Okay. Oh, let's see. Oh, I think, is this where the indentation is? Sorry, just always trying to get the syntax right. Yeah.
Is it with case or is it with pipes? Induction x's with and then pipe, not case.
Oh, yeah,
If
yeah,
you look at another example.
Yes, yes.
I'm just looking at the example. I don't remember, but
Oh,
it
you're
looks
right.
like case is a alternative to induction or something.
Yeah, yeah. There we
There
go.
we go.
Okay, that looks so much
Looks
better.
happier now.
I thought something was off. Okay, so we can do intro wise and maybe
Mhm.
maybe some can do this. Yeah,
Take zero wise. Okay.
and that should be a theorem, right? Let's take. Take zero, maybe?
Zero.
Yeah,
Or zero as in, oh,
there we go.
it was also completing to the zero with the ZEO. But
Yeah,
do we also have one with the?
so they're kind of the same.
Uh-huh.
Let's take zeros with the word zero.
Yeah.
Let's take zero. Oh, it's not here anymore. Okay. What's here?
Yeah, I introduced the one with the word zero because it somehow did not pick up that zero as a word and zero the number are the same.
Yes. So
Oh, interesting.
I thought we
We
had
need two variants.
Yeah, I thought we had both, but
I
I mean,
also
we do
thought
have
so.
both. I think.
Well, it was auto completing,
Yeah.
was it? Or it was? It wasn't. Sorry, it wasn't. It was not complaining. Oh, it
Ah.
is complaining now. Okay.
Okay.
Well,
Just took a while. Okay, but that worked.
yeah.
So here we can make a step, and here, so take should be able to take a step, and then we end up with something close to the induction hypothesis. So I'm gonna intro-wise and length should take a step, and take should take a step. Oh, no. No.
Something's off. Is underlining the
We should have suck.
the arrow.
Oh, it's just because it's not complete.
Oh, okay. Yeah.
The
that
error
always
just
gets
shows
me.
up in a weird place. Well, I mean, it's like if you're programming this, where would you put the error? You can't put the squiggly here because it's actually working. So this is kind of the best place you can pick.
Okay.
Yeah.
What I usually do is I have like in below the line where I'm working, I have another sorry. Then I just don't have the
Yeah.
arrow there.
Okay, yeah, we can work like that. Cool. Good fix. Yeah, then at least we know it's not a syntax error, so that's helpful. Okay, so we need this to be suck, or this one is the problem. I think it might be that this. How do we do that before? Let's see.
That looks quite similar to some theorem.
Yeah, yes. Okay. We can have cons basically. Says this is equal to this. Yeah. And then we can rewrite with this. And now we can say rewrite with take. Yeah. All right. So that was the issue. Right. We couldn't rewrite with take because we had it in this form and we needed it in this form. Does that make sense?
Yes, I just saw the theorem. I lost it again.
Yeah, over here. So
This app cons. I think it's that. This app cons in line 146. I think we can use that for rewriting.
yes, yes. Yeah, cool.
Might be more efficient than
Proving
throwing all the machinery of sim at it. Maybe the other, maybe backwards.
okay. Yes. Yeah. Yeah, perfect. Okay. Yeah, and now we should be able to apply Conger arg again. I wonder, maybe. Oh yeah, no, we need that. And then it's just the induction hypothesis. All right, that was a nice warm-up. Maybe now we can take on this min. So there's definitely a better way of doing this unfolding. But I can't remember it, or I don't know it yet. And when we do meta programming, we can simplify this later, but when we have this min function, we can unfold it, and then we get this. And if we have this, we can do a split, which finds this if statement and splits on the condition, whether it's smaller or equal or larger. So if we do split, okay, doesn't always work. Maybe we do sump. Yes, okay. Now we can do split. So it just removed, like this dot one says, give me, I think it's the first thing in the tuple or the second thing in the tuple, but there's only one thing in this tuple. Yeah. It just retrieves this function out of the tuple, basically.
In what?
Oh, this here we have
is this a tuple? Oh, it's a record. So
for a tuple structure. Sorry, that's the word for being.
Okay.
And then dot one is like just another way to address the field.
Okay.
Without using its name. So it's just accessing the first field or some field, I don't know, but it is this one. And then we just retrieve the function. So after we call simp, we just get the function with all the values filled in. And now we can do split on the if statement. Yeah, there we go. Oh yeah, wait. Oh, this is a neat thing I learned. Look here. So if you don't know what the case name is, you can just do your anonymous case with your backslash period. And then in the tactic state, it tells you what the case is.
Oh, nice.
Oh, that's nice.
So now you can go back and say, oh, well, oh, I think I still need a, yeah. No? I don't know.
Split case. Doesn't look like it. I think it is case.
Yeah. Let's go find another
What's
split.
it complaining about? Yeah. Case.
Like so. Okay. What is the
error? Tag not found. No quick fixes available. Oh, So you have to say, I mean, the other example, you've got suck.suck.inl and then H hypothesis.
Yeah.
But
Oh, it needs to be indented.
Oh.
Yeah. Sorry. This language is perfect for me because I say sorry so much. Okay. Oh yeah, that was the other one. So look, okay. So one thing the case does, the split does, it adds this hypothesis, but it's unnamed.
So you can name it. It's a second argument, is it, of the case?
Yeah. So you can say rename _I to go back and rename things in the stack. So we can go rename, maybe we call it C. Yeah, so now we know the condition is n is smaller or equal to length of x's. Whew. And now we can do induction on n, and then we would
Haven't we proven something like this?
oh, ooh, good call, good, maybe. This is the one for drop we've done. That looks very familiar. Yes, here we go. We have.
Okay.
Yeah.
Yeah, nice.
Very good. I think we can we pause and see? No? Can't read the whole error. Oh, it needs a net. Okay. There we go. Okay. And this is now not that.
Yeah.
I don't think we have that one, right?
Well, we have something with greater, don't we?
I don't think we do. I like this one. It might be helpful.
Isn't that the one we just used?
No.
No, oh no, it's the other way around.
Yeah. Yeah. No? You can't just do this?
I think H needs to have a type.
It's usually inferred. Like, supposed to be able to do this.
That's strange.
Oh, sorry. Okay, but this is all right. What Okay, let's just go back. What we want to prove is this. But this might be a nice theorem on its own. Right?
Mhm.
So maybe let's just do that. Mhm.
I think it looks strange though. I think we should put brackets around n and no, around before the n, and after the axis, because it looks like not n is less or equal to length.
Yeah,
I mean, maybe just a matter of text, but looked very strange.
yeah, no, I agree. I think we can even just say this. Like this is more a theorem I would like to prove. And
Yeah,
then we can fix the not thing in the in this proof.
yeah, I agree.
Hopefully.
Yeah, there should be a theorem in what is it? Basic.lean or something like that. Or
Oh,
order from dot lean. Mm,
yeah. But yeah, let's try to see if we can prove this one. So I think we can just do induction on in. And then 0. Width. Okay. Okay, I forgot. It should work like this. Okay. Oh, okay. Intro X's. Intro H. Okay, 0 is bigger than something is not a thing.
Yes, there's also a theorem
Yeah.
that this is false.
I think contradiction also figures it out. So
Ah,
yeah, we
okay.
don't even need to know what it is. So that's good. Okay, sorry, it's gonna take me a while to adjust to not delete the sorry, but I'll get there. Oh, we want our induction hypothesis to have a name. No. Oh, okay, now I can intro X's and intro H. Places on X's, I think, is a pretty good idea. So that we can take so we can take a step.
Oh no.
Cons. Rewrite.
Oh, well,
Rewrite.
that doesn't that axis clash with the other axis? I don't think you want to call it like head and tail or something, because we have axis before. Oh no, but it's deleted. There
Yeah.
because we do cases on it. Yeah.
Yeah. In Calc, you have to do the bookkeeping yourself and go X tick, X is tick. But
Yes,
yeah, it seems Lean does it for us. So
yeah, that's convenient.
yeah, it's very convenient. So I'm embracing it like fully. Yeah. Yeah, now we
Now we
can
can rewrite with take, right?
yes, and then length on both sides. So repeat. Yeah, so we have a little problem here in our hypothesis. But in the meantime, we can try to remove this +1. And I think hopefully Conger R can help us again. Maybe it's just suck. Please, please, please work.
Isn't it pred?
Hmm?
Isn't it pred? Like the predecessor that we have to take on both sides.
So Conger arc does like it removes something.
Oh, yeah.
Yeah.
I remember.
But maybe there is a way to apply pred to both sides. That would also be cool. Because this doesn't even work. So
Yeah, but you don't put the. I don't think you put the apply.
Yeah,
because it's just a function, right? So just Conger arc suck, and then you apply that.
Yeah. Yay! Yay! Nice. Thank you. Okay, so now we just need to get this in this form, and then we're done. So this almost seems like a theorem.
Yeah. Maybe there's a nicer way. Maybe we can already just at least rewrite length in this hypothesis. Yeah, so now we just have suck on both sides. Well, I think you've already got there's one called list length cons le suck. I think
list length cons.
Oh, sorry, aligned. Yeah, 323.
Yes.
Is that it? The wrong way. Yeah.
Yes. Nice. Oh,
why is it the right? Why it's slightly
it's
wrong?
just the wrong order.
Yeah.
But we can at least get ideas here.
Yeah.
Yeah, this is probably a private theorem. Yeah, because it's kind of it's useful, right? But there is a more general theorem here. We might even do this. Yeah. Where it's like suck n is smaller than suck m implies that n is smaller or equal to m. And that's just
isn't that
suck. Yeah. Yes.
Yeah. And that uses pred le pred. Yeah.
Yeah.
And I think for the greater than thing that we want to prove, we also need something like pred le pred just for the greater.
Yes.
Probably also with pattern matching.
Well, there's no greater than proofs. It's just less than or equal and less than. Okay, well, but we can do it.
Maybe there's a theorem that to go from the one to the other, because if the one is greater than the other, then we can swap them around and change the greater to less or equal. Let's check. How did you get to that order.lean? through the nut suck the suck.
Yes. Ah, where was that again? Yeah. Yes.
Oh,
So
I
this
don't get there.
suck GT suck. What we want. If we have this thing. Yeah, then we are done. But yeah, we still need it. But I did find out how to prove things like this. So I can show you because it's kind of something I learned on Stack Exchange or proof assistance. Stack Exchange, yes.
With the patterns.
Without the patterns. With
Oh.
yeah. So
Oh yeah, I saw the reply to your question, but I didn't look at it in detail.
yeah. So basically, we intro our hypothesis, right? And now we can do cases on our hypothesis. Let's just do width. Yeah, okay. So width would be, well, what's happening? Oh, sorry, no width. Raffle and step. So, okay, here we go. Sorry. Guys, step S. What did I do wrong? What did I do wrong? Oh, okay. Okay, there we go. Cool. We got the syntax. Okay, so we have to prove that suck M is bigger than M. Right? That will be our first case. And our second case is to prove N is bigger than M, given that M plus 2 is less than or equal to M in. That's not necessarily true.
M plus 2 is less than or equal to N. So M is less than N.
Oh yeah, that is true. Okay, good. Okay.
There's lots of inequalities switching to do.
Hmm. Yeah, but we can take some cheat codes because we. Oh, this is the first place. Okay, here we go. Yeah, so we're gonna need some of these. This we're gonna need some transitivity rule. I just know we will. Where are we? Here. Okay. I'll just leave this here for now. Here, maybe we can do just two constructor. Maybe we get lucky. Yeah. So if we just do constructor on the greater than, I think one of the constructors is just that you are greater than yourself. Yourself plus one is greater than you, right? So that's one way to construct a greater than relation. Yeah, that's the word. Thanks. Good. Now, for this, well, we need to swap things around, I think. So Gregor's idea of like, let's get the smaller, the less than or equal turned into greater than, or the greater than, this greater than turn into a less than or equal might be perfect.
Yeah, I'm looking for the definition of the greater than, the strictly greater than or strictly less. And I don't find it.
Well, there's a GT trans. Maybe we don't even need to. Oh no, we do. We need to swap one of them. Yeah. Oh, okay. It's dot swap. Yeah, but that's just an ordering type. It's not. That's not a relation. Okay. Oh, look at this. So greater than is just an abbreviation for the reverse.
Oh.
But yeah, it's not exactly what we want. We want to take greater than to
it's not strictly less than.
So can we go from less than to less than or equal? Or the other way around? Oh, here we go. Here we go. Ellie of LT suck.
Ah, nice.
Oh, what happens? No?
No, but that is slightly different to what I meant. That just says the successor if we have n less than where was it? Well, it says if we have n less than m, then yeah, less than or equal to m, then the successor of n is strictly less than m. So it doesn't switch it around, but maybe it works anyway. So I know it says, yeah, sort of what I said, just the other way around.
Yeah.
Uh,
I think actually what's weird is it saw the greater than as a less than or equal. Because I applied it, right, to the goal, and it worked. But no, it added a suck to both sides. That's so weird. Can I do suck with suck? Yeah. Okay, so
there's also a theorem. Oh yeah, I think this is closer to what I meant. Theorem nut.lt or GE. So it's either less than or greater or equal. And then we can just use that abbreviation.
Yeah, this is a predicted theorem, so we can't use it.
Oh, what does protected mean?
I know what private means and not private. Protected, I can't remember exactly, but
So protected is probably used in the package. Can be used anywhere in the package, but not external to the package.
Yeah, I think that's a good guess. Or is it your or do you actually remember? Because I get so confused with all the languages. Like,
no, I don't know. That's a guess.
Okay, yeah, but I do think it's a good guess.
Why do they do that? I don't see the point. It's a useful theorem, so why not make it available?
They would prefer if you like don't use it because they like don't want you to expose internals that they consider internals. But also we haven't used. Oh, is this or okay? Yeah. Okay, yeah. We also haven't done that. But it should be relatively simple to prove now. Like if we have this, we just need to add a suck on the one side.
No.
So that might be some version of suckless suck. This removes sucks or adds sucks and removes them. This is the one. Le suck. Okay, no. Okay. Let me see this. Yes. No. Okay, it says. Oh, no, sorry, my bad. This one. Le suck of le. And that gives us exact, yes. So it's just exact of this. Boom.
Nice.
There's definitely an easier way to do this, but it's just another good demo of seeing you can do cases on an hypothesis. But seeing how greater than and less than or equal can be swapped out. I don't know how they did that. So much. We might even have been able to apply the original. So let's
Interesting.
let's see. Okay. Not that one. Oh, this one, yeah. One of these. Okay, let's see. When we're here, can we do this? I think it's implicit. Yeah. See. We didn't even need to prove it.
Mm.
Yeah.
So you can even do, well, if we do. Well, let's have an alternative proof. And just go. Yeah. Now we can remember that they're so interchangeable. Crazy. Okay. Where were we? We wanted to prove this, that given n is bigger than the length.
Yeah, we just need to swap around the less or equal.
Oh yeah, yeah. But I think it might even do it for us. Let's see. How many parameters? 2? But these can also be implicit, right? What's the problem? What's the problem? Oh, okay.
Yeah, so this one, there is a theorem,
Yeah.
GT of not LE, or the other way around.
Mhm. Okay, yeah, so we couldn't get away with it. And then that should do a thing. Yeah, and this is exactly what we want.
Okay.
Yeah, sorry, Gregor, you were right. I needed to swap it around. I didn't listen.
Oh, nice. Yeah, this was not as bad as I thought it would be.
There's a bug here. Let's just see. This is correct. X's.
N greater than X's.
Oh, we don't need to pass
Take
X's. Yeah, there we go.
All right.
Cool. Yeah, yeah, right. Was it so easy now? we learned quite a few things over the past few months.
Oh, definitely.
So all these unfolds on starting at 675.
Mm-hmm.
So can you remind me again why these are necessary? Or what?
Yeah,
All these unfolds.
yeah, no. So we want to get to the if.
Yeah, yeah. So we want to dig in to get to the if.
Yeah, so if we unfold min, then we get this thing we
Mm.
probably don't want to see. Like
Yeah.
somehow we want to skip that, and then we want to skip that, and then we also don't want to see that, and then we get to the split. So
Yes.
there should be one thing, and maybe yeah. It's even rewrite
Yeah,
exposes
but
it.
wait, this inst min that.
Yeah. So it's some instance, because
Mm.
men is again an interface that's being implemented.
Right.
Yeah. Yeah. So we
Okay.
want a better way to do this that doesn't expose the internals, but I don't know what it is.
Mm.
I think maybe no. Oh, sorry. Yeah, I have it a lot of places. But yeah, so that's homework. You want to do another one? Now we have a minus sign we haven't looked at today yet. So
Yeah.
Hmm.
so yeah, let's just do the classic. What? Ah, sorry. There we go.
Well, -0, that looks like we can just simplify that.
Yeah, I think there we go. And oh, thank you, GitHub Copilot, for figuring out the rest.
Hmm.
No, sorry, it's sub 0. It's not 0 sub. Okay.
Well, that's interesting. So sub_0
Hmm.
is protected according to
Oh.
the, but we can still use it. So maybe protected means something different.
Oh, okay. Maybe I was wrong before.
But it's in simp.
It's in simp, though.
Interesting. So you can put stuff in simp, but then make it private or something. A bit bizarre, but there we go.
And somehow I can use it.
Yeah, somehow you can just
Ah,
if you you have to use it qualified. Maybe that's what it means.
qualified. Okay, so I was wrong before.
Yeah, me too. Well,
I prefer using them all qualified. If I kind of would prefer it to force me to use everything qualified.
What does that mean?
So
To
just
use
to
something qualified?
net dot in front.
Oh, okay. Yeah, it's
Can
like
you-
much clearer, like where it comes from.
can you import qualified? That's not a quick. We don't have to answer that now, but that's be interesting.
Yeah, I don't.
You do
Yeah,
qualified imports.
I would like that.
What's the point of protection?
Yeah, I can't remember the yeah. I read the book too long ago.
Mhm.
Oh yes, I remember now reading that actually about protected. The purpose of it is that like things that have like very generic names that might be used in other libraries that you don't that there's no ambiguity.
Hmm. Cool. Okay, so it is just about qualifying them.
Yeah.
Okay. Cool. Yeah, I think in this case we can just do rewrite with drop, rewrite with length. Yeah, now again, GitHub Copilot gets it wrong. It's the other way. 0 stub. Ah, close call, man. So close. Now we can rewrite with drop. And rewrite with length. And now I remember this.
Oh, +1 minus suck. That looks like it could be simplified.
Yes. I remember this. It was a struggle.
Is it? It looks so innocent.
Yes. It might be this. I think maybe we can, I think it's this sub. Maybe you can even qualify it there. Cool. Let's see if I got lucky. Yes, I got lucky.
Nice.
And that's just the hypothesis. So we're done. Yes. Cool. Next. Or maybe we skip ahead.
Ooh,
I don't know if I'm ready
the
for it.
Sigma. Sigma.
Yeah. Maybe this one is worth it to save for next time before we go into meta programming.
All right.
But maybe there's something else that's also interesting enough today. We have some ands we haven't done in a while or ever.
I
And
don't remember doing any ends.
we have a split function. Yeah. Let's try the split and then an and. What do you think?
Yeah, what does this even say? The split function. There are
Oh,
like 2 implications.
yes, so it just says, oh, and we have an and here anyway. So okay, cool. We're getting everything. So it says there's a list x's, which is the concatenation of y's and z's, right?
Mhm.
The length of y's is n. So that means that y's is the same as taking the first n from x's, and z's has to be the same as dropping the first n from x's.
Oh yeah, now that makes sense.
Yeah.
Mhm.
Are we happy to try this one?
Yeah, sure.
Okay.
It looks a bit involved, but maybe it just looks like it.
We're ready. We're ready. Okay, cool. We already got some reverted things here. That's great. I might reverse x's here as well. Yeah, we just have to decide if we're doing induction on n or x's. I think n would be nicer. It's just a guess. But yeah, please let me know if you think differently. Now, just wondering if we can intro already. Probably.
Length of y's is 0.
HL then, and H of paint. Oh, if length of y is 0, then y has to,
Why is it empty? Yeah, we have a theorem for that.
yeah.
Yeah, I think so.
Length, list length
0
0.
is empty. Yeah.
Okay, yeah. I was hoping that's a thing, but no. H empty, maybe? Yes. Yeah, there we go. So we can rewrite with that. And also rewrite with it at ha.
Probably also rewrite
Right.
this take, or there was take 0. We had a take 0 theorem, right?
Yeah, we can rewrite that. That's good. And we can rewrite with drop as well. Yeah, and you said, do you know
So we've
this
got something for that. List app nil R.
list app nil r? Okay, we'll have
That should be
HZs. Huh?
let's go. Oh, hold on.
Oh, it's just the wrong way around. Maybe just L.
But then it needs symmetry or something.
Oh yeah, symmetry. Okay,
How do we do that?
do we have some? Unknown tactic. Okay, do we have
EQ.sim?
dot sim?
Capital E. We've got apply. We have an apply EQ sim on
Okay.
line 143 that we've already used.
Hmm.
Must be protected.
No, we have it. I see what you're saying. Okay, I have it. We can go have ha.
Okay.
There we go. Now we swapped it.
Ah, right. So now we need to use the right version of that list app nil thing. Which way around is it?
Oh, left should be correct. Oh, but it's a different variable. We have Z. We can rewrite
okay,
it
so
with
it's not right. Yeah,
I think we can
rewrite. Yes,
yeah.
we want to rewrite one side of the equality with that.
I think we could have rewritten it before already. We didn't have to use the symmetry
Okay, yeah.
because it was just on the one hand side.
Okay. Rewrite list app null, right? At oh, yay!
Yay. Okay.
All right. And
We
now
can rewrite that in.
let's do
rewrite
symmetry on that just for fun.
Oh, okay. Yeah.
Just to have more references to this tactic that we forget about. Okay, now I think split would work. No. Okay, good to know. Cases. No, but I don't even know what to do cases on. Construct.
Yeah, it's in the.
Yes, constructor.
Oh.
That's just reflexivity, probably. Grapple.
Yeah, I'm just gonna. Okay. Yeah, we're good again. Yeah, rifle. Nice. And yeah, exact.
Okay.
Cool. This was pretty tough base case. Oh, this is gonna be interesting.
Yeah, can we intro?
Yes, let's do our intros. Okay, I think we have to do cases on X's because we want to be able to take and drop, I assume.
Right.
Yeah.
Oh, I wish Copilot could do this for me, but okay. I wonder if we have something for this. That would be helpful. But in the meantime, I'm going to rewrite with take, rewrite with drop. Yes.
Yeah, we have. Well, we have at least list app nil. That is if the concatenation of x's and y's is empty, then that's the same as x's is empty and y's is empty. In line 81.
Oh wow. Oh wow. Okay. X's, Y's. Let's see if we have it in the right order. Y's, Z's, yes, we do. I could say exact. Huh? No.
Yeah, it wouldn't be exact. I think it would just be. No.
Yeah, so it's an if and only if, isn't it?
Yes, yeah.
Does it allow you to do rewrite? Allow you to? Oh,
It should.
yeah, shouldn't it?
But otherwise we should be able to say apply. Okay, let's just see. Okay, I have to fill in x's and y's. It's not implicit, which is actually weird. Would be better to be implicit because you have to pass one of these anyway. Where's the other one? Yeah, you can rewrite using these ifs. Oh, but for the rewrite, I don't need to pass in anything. Oh shit. What did I do? It's just I actually use this.
If MP.
That's the
Modus ponens. Okay.
Yeah.
Oh.
So if you need to get it one way, because you couldn't figure out how to rewrite, which is exactly what. Okay.
Yeah, it's this.
No, but isn't rewriting just for equalities?
You, if only if, should also be able to rewrite.
Okay.
Yeah. So I can just for one. Let's just do this. There we go. Okay. So ha was in the wrong order.
Yeah.
So we needed to
Oh.
apply symmetry. And then we can rewrite at ha and get our goal. And we're done. Well, we're not done. All our base cases are done. Now we're ready to start proving. So now we can rewrite with drop and take and see what we get. This is almost helpful. Are we actually going to need our induction hypothesis? We can't use it. Oh, we can. Okay. We can pass in a wise with. Okay. If we do cases on y's, we can get y equals x. And then this y's will equal n, because this y's will become y y's.
Mhm.
There's a lot of nested cases.
Yeah. I'm like, do we really have to go through all this trouble? But we might. It is sometimes necessary because we have so many variables here. It is probably necessary. I think we have to do it. Do you guys have any other ideas?
No, I don't see anything else on the spot.
Okay, I'm gonna start going with it. We can always come back. Now I don't know how smart Lean is gonna be to clean this up for me, but let's see. Oh, it works. Yeah, wow. Yeah, amazing. Okay, anyway, we're still here. So here we have a contradiction.
Yeah.
So if we rewrite length at HL, maybe that should be enough to figure out contradiction. Yep. All right.
Yeah.
Cool.
We had 1 equals 0, so that should be good enough.
Yes. Now we should be able to rewrite this to get this. And then we should be able to rewrite this to get this. And yeah, since we're going to show that x is equals y, we'll be able to conquer arc and use, and then we'll get our induction hypothesis. So yeah, this should all, we're on the right path. So first things first, this should be doable. We rewrite
So we've got
length.
list length con suck. Is that? Yeah.
Oh yeah, we can just rewrite.
Oh
Yeah.
yeah, this length construct that's just proven by sim. So I think sim should get it.
Okay.
Yeah, I don't know if you can do sump at someplace, so but let's see. Let's see. Sump at HL. Yes. All right. Yeah.
Yay.
Cool. Okay. Yeah, that's actually even takes us all the way
Yeah.
there. Yeah, perfect. Okay. So that's done. Now we want this one to get x equals y. No, I don't know if we have any list cons proofs going on. Yes, this is the one we want. Does that make sense to everyone? Like, so we're just splitting. Okay. Cool.
Splitting one.
Yeah, I just don't know where to apply this. Rewrite at ha. What's the problem? Let's see. Is it the wrong way around again? No, we have what we want. Yes.
What's it complaining about?
Uh,
Did not find an instance of the pattern x x's y y.
yeah,
Yeah, because we've got that
yeah.
z's on the end.
I don't know what to call it. That's why. um, okay, there we go. Now we should be able to split. And we say destruct. Oh no. Can't say this in Lean 3, but no. Apply and intro at all, maybe.
Cases. Can we use cases here? With just one branch.
Yes. Suck cons intro.
Yes, it's a pipe, I think, before the instead of case.
Yeah, you're right.
Yes, it's strange. You just want to copy paste from them. Oh, maybe just intro in the when it's in a pattern.
Yay. Okay, we can give better names to left and right.
Is it Lucy Lefty?
Half for a paint and XY for equals Y. Amazing names. Now we can do rewrite with XY. And then we can do apply conger org. I hope. Oh, it's hard because we're inside.
Which one is it?
We're inside an and, so it's
Oh
kind
yeah.
of a problem. Is there anything else we can do before we split these and have to do everything twice? I think we can create our induction hypothesis.
Yes.
Yes. And now we can also split it.
Be right.
Yeah. No, we can split it.
No, we can't. Split it, yes.
Why not?
No, we can't rewrite, sorry.
Yeah, yeah.
I didn't see the conjunction.
Yeah, well, it did the naming really well. That's amazing. Now we can do rewrites. Instead of doing the split, we can actually just do rewrites. Oh, maybe the reverse is nicer. Maybe Riffle can do this. No. Sump? Yeah. We did it!
Oh,
Yay!
wow.
Oh, wow, wow.
3 nested cases, or induction and cases.
Yes. Yeah. One induction and 2 cases. And then these don't really count as cases. But they do make us nest, which is kind of, there should be a nicer tactic for this, but I don't know. Okay. How do we feel? Do we want to do another one?
Yeah. I'd be keen.
Yeah, which one? Maybe this one?
Well, that looks interesting. It also has an and.
Yes. And
Um,
not equal.
but what's the point of the 0 less than length x's? I mean, that's always true anyway. Oh no, it's not always true.
Yeah.
X's could be 0. Could be empty. But well, no, it could not be.
Yeah, but basically it's saying if x's is not empty, then its length is less than or equal to the whole list. Or we can do this one. If x's is not empty, then, because this might be a helper that we need for this proof anyway.
Yes, yeah. Looks like we can immediately apply it.
Yeah. Yes.
Yeah, let's do that one and then the other one.
Okay. Yeah, I don't see any way around. I think we have to do cases on x's or induction on x's.
I think cases on x's would be sufficient.
Okay.
Base case is just contradiction.
Yes. Yeah, good point. Oh, he even knows. Oh no. Oh. Yeah, we're done. GitHub code figured that one out, so that's okay. Wait, so
And what about that H there? It's not needed. I think that's why it's auto.
And then he just rewrote with length. And then, yeah, obviously this is true. Yeah.
Yeah.
Okay. Well, yeah, now we have to do this one.
Oh, it doesn't look too hard now with that other theorem.
Yes, it looks, yeah. Intro X's. Oh, yeah, okay, wait. We want to do induction on X's or Z's. Yeah, I
I
think.
would say on Z's.
Okay, Z's. Okay, let's try it again to that.
Because for everything we need to know about the X's, I think we can use the theorem we've just proven. And we
Yeah,
have the induction here, or the cases in that proof already.
Oh, Z's is so much harder to type than X's. I'm just.
They are right next to each other.
Next time I'm picking X. Just because of how weird it's so weird to like pinky. Ah. No, I'm kidding. I'm not kidding. It is hard to type, but yeah, no, I won't.
I'm using my ring finger for it. Like, how do you?
How do you type? Yeah. Yeah. Pairwise, and then what do we call this one? Yeah, that's everything. Oh yeah, and this is contradiction here.
No.
Oh, look at this.
Where does this come from?
Yeah. So this was supposed to be X's and Y's, X's and Y's, right?
Yeah.
And it was like, wow, I couldn't figure it out. Couldn't like that's a bit annoying. So we can go maybe let's try to help it out.
It's so wise on these stuff.
Yeah, but at least not underscores. Yes.
So if this is not empty, then, oh yeah.
Sorry. Okay. This is useless information. Might as well not have it.
Well, the one half is also the one half of our goal of our conclusion is also obvious. 0 less than length of some concatenation.
Yes, but yeah, we still have to prove it, but should be easy. And then this whoa. Actually, look at this. right?
Mhm.
So here we have x's is not equal the empty list, right?
Mhm.
This is the thing we're trying to prove. Over here they say z's is not equal
Well, z
z
is prime.
prime, right? That's the thing we're doing induction on. But we're not doing induction on x's, we're doing, oh, my bad. Okay. Let's try again.
That would have been very strange, yes. It suddenly plucked out.
Yes. Okay, so we have to do this. Okay.
Oh, yeah.
There we go. That's better.
Yeah.
Okay. So we're gonna no?
Was I didn't. So it's 8x's is not equal to the empty list. But then in the conclusion, we have length of x's is less than or equal to length of the empty list.
Yeah, but so it
So
has to
there's a
be.
contradiction.
Oh yeah.
Yeah.
Okay,
So
so
it
we
can't both be not empty and also have length 0.
yes. So if we can just show that x is equals the empty list.
Right.
Yeah, so it should be list append imp. No.
No, nil.
List
Trying
app.
to find it.
Oh no, yes. List app null L and no, actually this is not.
List app nil.
This is not what we want. List app null.
Right.
Yeah.
Yeah.
So let's see. Can we rewrite today? At yay!
Okay.
And
Now there should just be contradiction.
no, we first have to split.
Why not? Now we need a wreck it. Wherever it was.
Yeah.
Wreck it, Ralph.
Yes. Those good times. There we go. Yeah, we made a tactic in Coq called wreck it, and it would just
Oh.
break everything. Like just there's an end, just break it apart. Like it would just do like this for you, but you wouldn't even like need to think about it. It's just like, and you just end up with everything broken apart, and you go like, oh, that's equal to that. Okay, cool. Yeah,
That sounds very useful.
it is very, very useful. Sometimes too used. So, yeah, it goes too far, like where you break the abstractions and everything. But like, yeah, it was still very useful. Okay, yeah, we did that thing.
Now, this
Yeah.
looks more sane.
Yes, we can actually use this.
Yes. And x's plus y's. So.
Oh, and we don't
Z
need
prime there.
the primes anymore. Yeah.
Okay.
Yeah, so it wasn't Lean that wasn't too smart. It's we that were too stupid. He was like, oh, well, I guess you want underscores. Oh, we can, that's interesting. We can rewrite. I don't think we want to, but.
Can't we use like something like transitivity here? Because if 0 is less than length x's and length x's. Well, we don't have less than on both sides.
Oh, we already have that theorem, right?
Oh, yes, but I mean, if 0 is less than length x's, then 0 is also less or equal length to length x's. And if length x's is less than or equal to that other thing, then 0 is less than or equal. Maybe we can yeah, use some kind of transitivity there, and then it's just trivial because 0 is less or equal to everything.
Well, this is just saying it's bigger than 0, right?
Yeah.
But the other side of the end is finding an upper bound. It's not all like about the lower bound. It's the
Oh yes. My bad. Yeah, I missed that part.
Yeah, so but the left-hand side of that disjunction we can prove
yeah,
because we already know that x's is not the empty list.
yeah.
So definitely that length of x's is bigger than 0. So that bit is okay.
Yeah, we can do that so long. So we just have it here ready to roll.
Yeah. But the other one.
Oh, we might as well do it. Like, can we do? How do we do this again?
Oh, did you say rewriting? Sorry, I just noticed
Yeah.
we can rewrite this z concrete with the z's with that one. Yeah.
Yeah, yeah. And I'm just like can't figure out if it's useful or gonna like get in our way.
No, I think it's useful. It looks like a theorem.
Yeah.
Let's
because
see.
because it would like the reason I'm worried it would get in our way is that then it means we can't use the induction hypothesis.
Oh yeah, that's true.
But
I mean, we wouldn't
Length of
need it
x's.
because
No, look at it. Yeah, because length of x's is less than or equal to length of x's
yes,
concat
okay,
wise
we
without
would,
the induction hypothesis.
yeah, you're right. We wouldn't need it. Okay, all right.
we don't even, yeah, we can just do cases instead of induction.
Okay, so let's.
Length of x's is less or equal to. We already proved that.
Yeah. Okay, so we have to split this end.
Yeah.
Is it? Yeah.
Yeah, and we have this theorem list app length.
At length. Yes. But we need to do some
I
work.
get rewrite. I would rewrite, not apply it.
Cool,
And
cool.
then
Nice.
yeah, that looks
That looks like a thing. Looks like it should be a theorem.
yeah, can't we just do cases on the length of y's? If it's 0,
I think it's just a theorem like net LE add. Or we just say for
LE add right.
Yeah. So just this.
Oh, it's in
Yeah.
the.
Is it in
It's in
that?
the. It's in the. It's in the standard library.
Oh,
LE add right.
Ellie add
I
right.
think it's right. And what? Or left.
Okay, great. Yeah, that's it. Okay. So it just says, yeah, if you add something to less than or equal, then yeah, it is less than or equal.
Yeah. Nice.
Excellent.
And then we just.
We're done. Like that's
Oh, is it done?
Yeah. that's the whole.
You don't have to show that the. What's it?
No.
No, we did that already. The other half,
Yeah.
the left half.
Okay.
Yeah. GitHub Copilot did that for us. I really don't understand how it works because sometimes it's so smart and it uses the context so well, and other times like what?
Wow,
Okay.
it's not much left.
No. So these are definitely just exercises for we can leave. Maybe this, so, and maybe we'll start with these two next time, and then start doing some meta programming.
Yeah.
Yeah, but these two I'm just
Hmm.
gonna leave to anyone who wants to make a pull request. These four.
Yeah, they look very simple.
Yeah, and it's nice to leave some exercises for people who want to learn and contribute to a repo. Because they all look true.
Yeah, that's the thing I was going to say. As long as they are true.
Yeah.
So
Yeah,
we
I
build the
copied
whole
it somewhere, so I think like I think we're fine. But yeah, these two will be, well, this one will at least be interesting for us.
Yeah.
Yeah, I haven't worked with the existential quantifier
Yeah.
at all.
It's a pain, but it's very, very doable and very necessary. But then also like we're gonna start reading the meta programming book for Lean, and then try to see if there's anything really simple we can start with in there, like just really simple building tactics. But yeah, so there's a book I've linked from the repo that, yeah, I've started to read. It's written pretty well so far, with lots of actually really nice examples and exercises.
Yeah, it's still being written, I think.
Yeah.
But and yeah, there are exercises with solutions.
Yeah. But so far, pretty impressive, like thorough, and yeah, it competes with the normal lean books that are out there already. It's high quality.
That's cool. Yeah, I haven't had a look at it yet. I just opened the link.
Yeah. Maybe I can also show.
Oh yeah, I remember I
There's-
opened it before, but I didn't read it. It's
Yeah,
so cool
yeah.
that it's all in Markdown.
Yeah. Oh, there's a PDF as well.
Oh, okay.
Yeah, but
But it's probably just the Markdown rendered as a PDF, compiled to a PDF.
I think so. But yeah, I am reading it in the Markdown. Yeah, it's nice because you can keep your place. Like you can click here and then, okay, now I have this link and I'm reading from here. Yeah, because I'm reading it on my phone.
Ah, okay, yeah, that's nice.
Yeah. But yeah, and I'm only at the meta aim chapter. I still have to. I only read these 2 chapters, but they were good. So yeah, but I'll end the stream there, and then. Oh, there's someone was there, and I didn't reply to Isviren. Oh, thanks for the suggestions, and sorry for not. Oh, Andor.
Whoops.
Hi, Andor. I'm sorry for not looking at the chat. Yeah, I'm not at my base today, but thank you so much for watching. And yeah, I'll say goodbye and hope everyone has a great day. Cool.
Bye.
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 Let me see. Oh, I say that, but then I still have to click in somehow. So let me stop live. Bye, Andor. See
Bye.
you on the Zoom next time. Yes.